to see various types of the DC motor. Okay, so only the single topic we are going to cover today only, that is a type of DC motors. Okay, as we have seen in a generator case that there are various types like a separately excited DC generator, self-excited DC generator, then again self-excited becomes classified into three types, that is a shunt wound, series wound and compound wound self-excited DC generator. So same like DC generator, DC motors also classified in the same type, so we will see one by one. Okay, so whatever the topic we are going to cover today, the question is here, list out different types of DC motor. That is question number 2. Okay, it has been asked for the 4 marks in November 17 examination. Okay, again also this question is asked in November 17 October. Okay, that is a or question, that is list out and explain different types of losses in a DC machine. So once we will clear the types of DC generator, then we will go for the losses. Okay, so yesterday I think I have given one assignment question. So have you guys completed that question? सगळ्यांनी लिहिला का काल दिलेला क्वेश्चन? हॅलो श्रेयश, am I audible? Yes, tell me, लिहिला का क्वेश्चन काल असाइनमेंटला दिलेला, टॉर्क इक्वेशन ऑफ डीसी मोटर? Okay, 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 fine. Okay, the next assignment question for today is list out different types of DC motor and explain them with correct diagram. Also write equation of back EMF for each type of motor. So this topic we are going to cover today. Okay. So before that, the small point we have missed yesterday. Yes, Sreyash. एक 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 क्वेश्चन लिहायला सुरुवात करा, जेणेकरून ज्या दिवशी आपला शेवटचा टॉपिक होईल, एका ह्या युनिटचा ज्या दिवशी शेवटचा टॉपिक होईल, त्याच्यानंतर लगेच दुसऱ्या दिवशी मी पूर्ण असाइनमेंट चेक करणार आहे. त्याच्यामुळे एक 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 जसं होईल तसं तुम्ही लिहित जर गेला तर तुमचा ऍज पर ट्रिपल पी स्टडी पण होतोय, तुमच्या नोट्स पण निघतायत. येते का लक्षात? सो तुम्ही लिहिताना हवं तर हे ट्रिपल पी पेजेस वरती लिहा. हा हा नाही नाही, ऍक्च्युली मला वाटतं मी तुम्हाला एक बीएल थेरेजाचं बुक हे केलेलं आहे ना, फॉरवर्ड केलेलं आहे वाटतं. ठीक आहे, मी बीएल थेरेजाचं बुक तुम्हाला मी ऑलरेडी फॉरवर्ड केलेलं आहे. अजूनही मी तुम्हाला 14 तारखेला कॉलेजवरती गेल्यावरती पीसी मधून जे माझं बुक आहे बीएलटीचं, बीएल थेरेजा, त्याच्यामध्ये सगळे युनिट्स कव्हर आहेत. तर ते मी काय करतो की ते परत आपल्या ड्राईव्हची जी लिंक आहे तिथं ते अपलोड करतो, जेणेकरून तुम्ही तिथून परत त्याच्यातूनही घेऊ शकता. आणि 14 तारखेला मी डीसी मोटरच्या हँड रिटन नोट्स ज्या आहेत त्या स्कॅन करून त्या पण अपलोड करून देईन, त्या पण तुम्ही पाहू शकता. ठीक आहे, त्याच्यातून मग तुम्ही तिथून पुढे क्वेश्चन्स लिहायला चालू करा. बट युनिट संपल्यानंतर मला दुसऱ्या दिवशी लगेच सगळे असाइनमेंट क्वेश्चन्स रेडी पाहिजेत. जर त्याच्यानंतर तुम्ही असाइनमेंट्सला तुम्हाला मार्क आहेत, ओके, सो जर तुम्ही त्या दिवशी नाही चेक केला, दुसऱ्या दिवशी चेक कराल, 1 मार्क कट होईल. तसं जसं तुम्ही एक एक दिवस वाढवत जाल, 1 1 मार्क कट होऊन जाईल. सो चॉईस इज युअर्स. ओके, सो yesterday we have seen that equation. Okay, so we will cover this short part and then we'll go for the types. So we have seen that is a EB is equal to V minus IA RA, right? So what we have done, we have multiplied by IA with each and every point. Okay, so we have multiplied by RA. So once we will multiply by IA, at that time this term will become a mechanical power developed. So I will write here as a PM, mechanical power, is equal to, again this VIA will become as it is VIA, that is the electrical power input, minus IA square RA. Okay, so this equation we got here, P mechanical power is equal to VIA minus IA square RE. Okay, so now what we will do, we will differentiate this equation, we will differentiate this equation with respect to IA. So once we will differentiate this equation with respect to IA, then this left hand side will become 0, because there is a PM and there is no any part of IA. So differentiation तुम्हाला येत असेल. Second part, V is a constant term. IA's differentiation is 1, that's why it will only V. Then RA is a constant part, I will write as it is. IA square's differentiation is 2IA. Okay, so now what I will do, I will shift that minus 2IA RA to the left hand side, so it will become V is equal to twice IA RA. Okay, now again this 2 will shift this side, so it will become V by 2 is equal to IA RA. Okay, so now we know that V is equal to EB plus IA RA. Okay, but right now we have the value for IARA. IARA's value is nothing but V by 2, so we will replace this value in this place. Okay, so once we will replace this value in this place, it will become V is equal to EB plus V by 2. Am I right? Okay, now this V is equal to EB plus V by 2. Now V by 2 is for addition in right hand side, so we will shift it to the left hand side, it will goes to subtraction. Then V minus V by 2, it will become V by 2. Okay, so we will remain that V by 2 is equal to only EB. Okay, so then that means what? When our power will maximum, the power will maximum when back EMF is equal to 1/2 or the 1 by 2 of supply voltage. Okay, so we can state that gross mechanical power developed by the motor is maximum when the back EMF is equal to half of the applied voltage. Okay, sometimes in a viva questions as well as in an interview, you may be asked like a question, when in a DC motor when maximum power will we get. So we can state that in a DC motor gross mechanical power will be maximum when the back EMF is equal to the half of applied voltage. Okay, so that condition is not realized or active in a practical session. Okay, because in that case our current is beyond the normal current of motor. Okay, so that's why in a practically this is not possible. So half of our input will be wasted in form of the heat as well as other losses, whichever mechanical as well as magnetic losses. Okay, so the motor efficiency will be always below to the 50%. Okay, so this is the condition for the maximum power. Okay, so that point I have mentioned yesterday, so I have taken in consideration for today's lecture. So I hope you have understand that when maximum power will occur and what will be the explanation for this with help of the that expressions. Okay, any doubt in a condition for maximum power? And everybody is clear? Okay, fine. Now we will see one small or basic example. Okay, as compared to DC generator as well as a DC motor. Okay, so a 220 volt DC machine. See, they have mentioned that is a DC machine, not any DC generator or DC motor. मोटर म्हटलेलं नाहीये किंवा जनरेटर म्हटलेलं नाहीये, त्यांनी काय म्हटलेलं आहे, डीसी मशीन. ज्या मशीनचा आर्मेचर रेजिस्टन्स हा 0.5 ओहम आहे. सो दिस इज दी 0.5 ओहम रेजिस्टन्स. ओके, if the full load armature current is 20 ampere, armature current 20 ampere is given. Find the induced EMF when the motor machine act as a generator as well as a motor. Now here is the question. Question is what? Find out the induced EMF in case of generator and in case of motor. So I have already told you that many times I have revised. For generator there is a separate formula, for motor there is a separate formula. Only small change is there about plus and minus, right? So for a generator, that E is equal to V plus IRE. For generator, that E is equal to V plus IRE, and for motor, that back EMF is equal to V minus IRE. So you can check here only the difference between this formula, and once we will clear with that formula, that motor is E in motor case, E is equal to V minus IRE, but in case of generator, E is equal to V plus IRE. Okay, so if you clear this question, this exam formulas, then you are able to solve the formula, that you know that voltage is 220 volt, armature resistance is a 0.5 ohm, armature current is 20. All the things, all the parameters are same. Only the difference, for the generator there is a positive plus, for the motor there is a negative symbol. Okay, so I hope you have cleared. So once you will solve this, you will get the 230 volt for generator to 10 volt for the motor. Okay, so I have already, many times I have already revised that there is a only small change about the generator and motor while you are going for the calculation of induced EMF in case of when voltage and armature drop you are known. Then for generator case there is a positive, that is a plus, voltage plus armature drop is equal to induced EMF in case of generator, and voltage minus armature drop is equal to back EMF in case of the DC motor. So now we'll move for the main our topic for of today's agenda, that is the types of DC motor. So as DC name is being shown, that the direct current motor. Okay, already we have seen the basics yesterday. So in the DC motor, connection of the field winding with the armature winding, that defines the type of, or that classifies the types of DC motor. So what is the structure, what is the way of connection of field winding with the armature is the main thing. So as per that connection, according to that connections, there are major two types. First one is that separately excited DC motor, and another one is a self-excited DC motor. So as we have already seen in a case of generator, there are also separately excited DC generator and separately excited, self-excited DC generator was there. So same thing here is, only word is replaced by motor in case instead of generator. Okay, the same two types are there again, but we know that self-excited DC generator were classified into three types, that is a series, shunt and compound. Similarly, DC motor also classified, self-excited DC motor also classified into three types, that is a shunt mount, that is a shunt motor, series motor and a compound motor. Okay, so as we know that DC motor converts electrical power to the mechanical power, then the construction point of view, the DC motor and generator both are the same in case of construction. But the DC motor having very good range of the speed regulation in electrical traction applications. So electrical tractions means what? In a railway section, in railway industries, there is a major applications and a very good speed regulation of a DC motor is present. So the working principle, again we know that working principle of DC motor is depends on the Faraday's electromagnetic laws, which states that current carrying conductor placed in a magnetic field then it experiences force. So already we have seen all the things, and these some kinds of little bit applications like explorers, little bit drives, tractions, the DC motor is used. So we will go for the type. So first type, that is separately excited DC motor. As everyone is clear about the statement of separately excited, self-excited, I have already explained in DC generator how there is a residual magnetism, how separately excited motor requires this very separate DC supply, external DC source. All that things I have already explained. Again, I will revise one thing by using the figure which is shown in this corner, this figure. Please refer this figure. So as the name signifies, the field coil or the field winding of a motor is energized by the separate DC source, or we can say by using battery, or we can say that is a external battery circuit is used to excite the field winding. Okay, so all these things are same like a generator. So that's why the separately excited name is given to the motor which is excited by the separate DC source or separate battery circuit. Then next point, next topic or next type is a self-excited DC motor. Okay, so again, as that name implies, the DC motor, self-excited DC motor, in this type of motor, the field winding or the current in a winding provided by the motor itself. So as we know, in a generator case, small amount of current is produced, which is used to excite the generator itself. So same like that in case of motor, that the current in a windings which is provided by the machine or the provided by motor is causes to run or to excite the field winding of a motor. So that's why it is known as a self-excited DC motor. Again, it is divided into three types, that is a series wound, shunt wound, and compound wound. Okay, now we'll go for the one by one. That is a shunt wound means what? Already we know shunt means parallel. That parallel means what? There is again connection between field winding and armature winding only. So in a shunt motor, here in this figure you can see the corner, in a bottom corner you can see that field winding and armature winding both are connected in parallel with each other. Okay, so that's why that motor is known as the shunt wound self excited DC motor. So again we'll go for their voltage, power, current equations. Okay, so if once we will apply the KVL, that in figure I have shown here red dot, see. So at that place we will consider this is a node. Then at that node, if we will apply the KCL, that is a Kirchhoff current law, that is equal that status incoming sum of incoming current is equal to sum of outgoing current. Okay, so if we apply the KCL at that junction A, then sum of incoming currents at this point is equal to I. Okay, so if there is IL is equal to IA plus ISH. Okay, so here only EL is missing. Okay, so IL is equal to, see there are two currents which are outgoing and one current is incoming. So incoming current is from load, that is IL, and outgoing currents are ISH and IA. So we will use the KCL that states sum of incoming is equal to sum of outgoing. So IL is equal to IA plus ISH. That means load current is equal to armature current plus shunt current. Okay, so again we know one more thing, that if we apply the KVL at the field winding circuit, then we know that the voltage V is equal to ISH into RSH. That is nothing but drop at this place, because this place and this place, both place are same. So in parallel voltage is the same, so voltage is equal to voltage drop across the field winding circuit, that is ISH into RSH. So this is equation number 2, and we again apply the KVL to the armature circuit also. So in that case again this V voltage is equal to, there is again appearance of back EMF, so voltage is equal to E plus IA into RA. That IA into RA is nothing but armature voltage drop, and that E is nothing but back EMF which is in upward direction. That is why we are taking it into addition forces. So the voltage is equal to E plus IA RA. So 1 2 3 equations we have calculated from the figure. Then go for next. Now we know that voltage equation we have calculated. See in this figure, in this page we have calculated current equation, we have calculated voltage equation. Okay, so I think there is no doubt to anyone. If any doubt, please let me know. Any doubt? Hello, I am only just speaking and speaking. You guys are just listening or sleeping. I don't know. Understand, na? Okay. Then we now right now we have calculated voltage as well as current equation. Now we'll go for the power equation. Okay. So in that power equation, we know that power input, that means electrical power input, is equal to that mechanical power developed plus whatever the losses are available in armature and field. Okay, because if there is a current, then there is a losses. Okay, so there are losses in field winding, there are losses in armature winding. So addition of these two losses, that is total losses plus mechanical power developed, is equal to electrical input. Okay, so now we know that electrical input is a VI, that is a voltage into current. Then mechanical power developed is a MP PM, that is a mechanical power, which is equal to back EMF into current. Then losses in armature. Armature losses is nothing but copper losses. So we'll consider that Ia square Ra, and again copper losses in field, that is ISH square RSH. Okay. Now one thing we know, that if we'll write that ISH square RSH like this way, ISH into ISH into RSH. Now RSH into ISH into RSH, we know that it is a V. So that's why we will replace this ISH into RSH into V. So one ISH will remain. So V into ISH will become there. So PM as it is, Ia square Ra as it is. But in that case, we have substituted VISH. Why this is coming? Because ISH square is nothing but ISH into RSH. But we know that ISH into RSH is equal to V. We know that from this equation 2. So we will replace that equation in that case. Okay, now we'll go for the next step. If we, what we have done, we have shifted these two equations or two values to that side. So once we will shift these two sides, so Vi minus VISH minus Ia square Ra. Now again in these first two values, there is a common term V, so we have taken out, that is a V. Okay, and then Ia minus ISH will as it is, and Ia square Ra is also Ia as it is. Now see, now this I minus ISH will go for this equation. PM is as it is, this minus Ia square Ra is as it is, but here V is also as it is. Only the value is changed. I minus ISH is equal to Ia, but from equation 1 we know that I is equal to Ia plus ISH. So if we will shift that ISH to left hand side, we will become I minus ISH is equal to Ia. So this equation will be replaced here. I minus ISH we have taken as a Ia. Again Ia will be common term, so we will take out that term as a common. So Ia will be taken out common, then only term remains in the bracket. V is equal to V minus Ia Ra, and we know that V minus Ia Ra, just a minute, in that equation, see, I will show you equation 3, this equation. So E is equal to V minus Ia Ra. So in case of this V minus Ia Ra, we can replace by the E. Okay, so this PM will become, that mechanical power developed will become EIA. Okay, it become EIA. So if we will to find out, again we have another way to find out the equation, like if we will multiply in this equation 3. Okay, this equation, if we will multiply by Ia or every term, then we will get IAV into EIA into Ia square Ra. And if we will compare this equation to this, okay, then we easily understand that VIA means power input, and this mechanical power developed is EIA. So here also we have obtained EIA is equal to mechanical power. So any doubt in power equation? Is there anyone who are listening to me? Any doubt? Okay, shall we go for next? Okay, so next type is a series wound. Already we have seen separately excited, then shunt field, self excited. Now we are going for the series wound self excited. Now only the change is in according to connection of field and armature. The difference is that in shunt winding both are parallel to each other, but in that case field winding as well as armature winding, both windings are in a series with each other. So see here, you can see both are series. Okay, now the current flowing through the winding is same. That means load current is equal to series field current is equal to armature current. So here by KCL, I is equal to I is equal to ISE is equal to IA. Any doubt in that case? About the current equation, any doubt? See, you have to write the question. Assignment question number 2 is based on these three types, and these are the back EMF equations, whatever we are going to see. Okay, so that equations means what? Current equation, voltage equation, and power equation. You have to write, then and only then you will get the out of marks. Okay, so current equation is nothing but in series. All in series we know that current is the same quantity. So I is equal to armature current is equal to series current. Now we'll go for the voltage. So now again, if we apply KVL, if we apply KVL, then this V is equal to, first of all, this back EMF will be taken into consideration. So V is equal to EV plus IaRa into IaRac. See here we have taken Ia, Ra is a voltage drop across armature, and ISE, RAC is a voltage drop in field winding. But we know that IA and ISE both are equal to Ia. So what I will write, I into RA plus RAC. हे आलं का लक्षात? कसं आलं ते हे इक्वेशन नंबर 8. Okay, now we'll go for next. Now again same, to find out the power equation we have to multiply by I to the both side of the equation. So if we will multiply by I, this side also we will multiply by I. So I into V, VI, E into I, EI. So here if we multiply to I, then I will become square. Okay, now to find out the power input, here easily see power input is equal to VI, mechanical power is PM, losses IA square RA, and losses in field I square RA. So now the mechanical power, if we compare these two equations 9 and 10, then we know that VI as it is, that PM is equal to, what is the value for PM? That PM is equal to E into I. So this is the power equation for series wound self excited generator. Clear? Yeah. Now last point or last type of the DC motor is a compound. Okay, so in that motor, compound means what? The motor which having the one field winding in a series with armature and another is in parallel. Okay, so already same thing, same terms we have cleared in a DC generator. Okay, so here one field winding is connected with parallel in series with armature, and both whole circuit, that series with armature is circuit is in parallel with another field winding. That means there are two sets of the field winding. Okay, so the motor which having shunt as well as series winding is known as a compound motor. Now again, that compound motor is also divided into or classified into two types, that is a cumulative compound motor and differential compound motor. Okay, so in cumulative, that means flux produced by the both winding means what? Shunt winding and armature winding are in the same directions. That means if both are in same direction, that means there is a total fluxes which will be addition of the total fluxes prepared or generated by these two windings. So phi r, that phi r is nothing but resultant fluxes, is equal to phi sh plus phi se. That phi sh means fluxes produced by the shunt winding, and phi se is nothing but fluxes produced by the series winding. Okay, now about the differential, in that case, in differential case, the fluxes produced by these both winding, that series field windings and shunt field winding, both fluxes will oppose to each other. That means resultant fluxes will become the difference between these two fluxes, that is phi sh minus phi se. Now that positive and negative signs which will explain us the direction of fluxes produced by the field winding, that plus sign will direct us that is in a same direction, and this minus sign will shows us that is a different direction. Okay, so sometimes in an interview or in a viva questions there is a question like why differential compound motors are not using, or it is using rarely, why this motor don't have any applications. So that time you can explain, sir, as there is a fluxes production of both winding, that is a flux shunt winding and series winding, but these both fluxes will oppose to each other, that's why there is a weakening of fluxes. And if there is a weakening of fluxes, then that means what, there is a less amount of induction of emf, so due to that there is a many losses. So that's why this motor is not used maximum places, that is why reason the motor using rarely case. Okay, so this is all about the types of dc motor. Okay, so I think every point about the types of dc motor you have cleared. Okay, if any doubt please ask me. Which one? This equation, na, phi sh minus phi se. Okay, see, first thing, read this statement. Okay, in cumulative compound motor, the flux produced by both winding. Which windings are present here? Here are two windings. One is a series winding, another one is a shunt winding. Now, in a cumulative compound motor, flux are produced by the both winding in a same direction. Okay, now you see, if there are same directions. Okay, now here we will consider as per KVL, Kirchhoff voltage law. I think you have learned in a first year. Okay, so if there is a same direction, then there is addition. But if there is a see, if one current is flowing through this direction and another one is flowing through this direction, so at that time what happen, if this is a 10 ampere current and this is a 5 ampere current, आता जर सपोज तुझ्याकडे काय आहे, तुझी ताकद आहे 50 किलो आणि तुझ्या समोर एक 100 किलोचा पैलवान उभा केला, तो तुला ढकलतोय, तू त्याला ढकलतोय, तर कोणत्या बाजूला जाईल? तू त्याला ढकलत नेशील की तो तुला ढकलत नेईल? 100 किलोचा पैलवान तुला ढकलत नेईल, बरोबर? बरोबर का? म्हणजे काय, इथं हा 10 एम्पियर, इकडे हा 5 एम्पियर, तर हा 10 एम्पियर काय करतो, यातल्या 5 एम्पियरला पाठीमागे ढकलतो आणि वरती एक्स्ट्रा 5 एम्पियर तो खाली जातो. म्हणजे काय होतं की जेवढी अमाऊंट जास्त म्हणजे डिफरंट असेल, थोडक्यात डायरेक्शन वेगळी असेल, तर तो काय होतो, सबट्रॅक्ट करतो. आणि जर सपोज दोघं एकत्र असतील, आता सपोज तू 50 किलोचा आहे, आणखी एक 50 किलोचा, आणि तुम्हाला एक दगड ढकलायला सांगितला, तर तुम्ही काय करणार, एका डिरेक्शन मध्ये दोघांचा फोर्स ऍड होणार आहे ना, त्याच्यामुळे ऍडिशन होणार दोघांच्या ताकदीची. सेम थिंग, दोन करंट जर एका ह्याच्यात असतील किंवा फ्लक्सेस एका ह्याच्यात असतील डिरेक्शन मध्ये, त्यांची ऍडिशन होते. तर ह्याच्यामध्ये काय होतं की जेव्हा सेम डिरेक्शन मध्ये फ्लक्सेस असतात त्या टाइमला फ्लक्सेस हे ऍड होतात. दॅट मीन्स फ्लक्सेस प्रोड्युस्ड बाय द शंट वाइंडिंग अँड फ्लक्सेस प्रोड्युस्ड बाय द सिरीज वाइंडिंग विल गेट ऍडेड. बट इन केस ऑफ डिफरन्शियल, what is the statement? Read it. The flux produced by the series field winding is opposite to the flux produced by the shunt winding. So I hope now you have cleared. Yeah.